Acid deposition is one of the things that can happen as a result of air pollution. It is considered one of our secondary pollutants because it's usually a chemical reaction between one of our primary pollutants and water vapor. So an acid is any chemical that releases hydrogen ions when it's been dissolved in water, and we use the pH scale to express that hydrogen ion concentration. When we talk about pH, each change in pH is a tenfold change in the hydrogen ion concentration. So something with a pH of 5 is 10 times more acidic than something with a pH of 6. So water and carbon dioxide naturally react in the atmosphere to form carbonic acid, which has a pH of 5.6. So natural rainwater already is slightly acidic. Acid deposition is when we lower that pH lower than 5.6. So one of the main sources of the pollutants that lead to acid deposition are coal-burning power plants, also ore smelters. Remember that ore smelting is when we are removing the metal ore from a rock. And then other industrial plants that are also emitting that sulfur dioxide. So 70% of acid deposition comes from sulfur dioxide. The other 30% is nitrogen oxide. So the sulfur dioxides and nitrogen oxides, if they convert to sulfates and nitrates, that is considered dry deposition because they are dry solids. If they combine with water vapor, they become sulfuric and nitric acid, which is wet deposition, or what we usually refer to as acid rain. So sulfuric acid is when you take sulfur dioxide, or SO2, combined with water vapor, and then nitric acid, you take nitrogen dioxide, which combines with water vapor to form nitrous acid, and then that in turn also produces nitric acid. So wet deposition not only includes acid rain, but also fog can have a pH of lower than 5.6, snow, and even cloud vapor. And then dry deposition, as we said, those are the solid particles. Now, it's a regional problem in the eastern U.S. That's where we have most of our coal-burning power plants, many of our smelters, or also we have large cities that have cars that are burning petroleum as well. The areas that are most sensitive to acid deposition are those that have thin, already acidic soils. And this happens a lot in western North Carolina. We've got a lot of granitic or granite rock that doesn't have natural buffering. Limestone has a pH of higher than 7, so it's going to naturally buffer the acid rains. So what happens are our mountaintop forests tend to be hit the hardest. They're going to block the clouds and they're going to get more of that acid deposition. And also on top of that, carbon dioxide is more soluble at low temperatures. So at those higher altitudes, your rain is already going to be naturally more acidic. And so what happens, those trees are sitting in the fog, they're sitting in the clouds at their high altitudes, and they're going to be affected by that acid deposition. So some of the effects, we see the effects on the leaves and needles of the coniferous forests. If our bodies of water are affected by acid deposition and their pH drops below a 5, then that affects our fish population. And when the fish start to die, then they sink to the bottom, and you've got a lot of undecayed material because the decomposers can't process it fast enough. We get a lot of mosses in the inshore areas, so productivity drops in those bodies of water. It can damage statues and buildings. I know my face is in the way, but if you look up here, you can kind of see a before and after of a statue. We used to use limestone and marble for a lot of sculptures and gravestones, but they dissolve very easily from carbonic acid, so now we use more granite. It also can affect the finishes on cars as well as other surfaces. Acid deposition can lead to health problems. It causes bronchitis, it can aggravate asthma, and then we also have reduced crop yields. For the same reasons that affects the trees, it's going to affect all plants as well. The toxic effects are when it lowers the pH or creates that acidity in the lakes. One of the things that happens is that aluminum from the runoff is absorbed, and that can be toxic to the marine organisms. It also, the acids can leach other metals out of water pipes. So if you've got lead or copper pipes, especially in really old homes, that can affect the drinking water. It can also leach nutrients out of the soil that can affect plant growth, and it can release aluminum, which when the trees are drawing in aluminum, it actually makes it harder for them to take up water. Some of the things that we can do to help prevent the problems of acid deposition: if we increase our efficiency, so we are not using as much electricity, that's going to cut down on the amount of coal that we are burning and releasing that sulfur dioxide into the atmosphere that leads to sulfuric acid. Switching to natural gas, because burning that is cleaner, it has less sulfur. Using our renewable energy sources, reducing our emissions by making cars more to use less miles per, or you get more miles per gallon, they're more fuel efficient. Using public transportation. So if we can prevent these pollutants from entering the atmosphere. If we can't prevent it, if we can regulate it. So when we do burn coal, have scrubbers on the smokestacks to help remove some of the sulfur dioxide. Catalytic converters in cars can help cut down on the nitrous oxides. Once the damage has been done, there are things that we can do to help restore. In the early 80s, they were liming, which means basically it's like crushed limestone, putting in the Swedish lakes to try to raise the pH. And of course that's going to have other problems, but one solution. International agreements. United Nations Convention on Long-Range Transboundary Air Pollutants was one in 1979 that strove to cut down on the amount of sulfur dioxides and nitrogen dioxides that were put into the air. The last thing, kind of unrelated to acid deposition, but we do need to talk about it, is the urban heat island effect. And we've mentioned this a little bit before, but one thing that happens because the amount of ground level air pollution in cities is that they tend to be warmer. They're also rainier and foggier than the suburbs and surrounding areas because they have more solid particulates in the air, which becomes condensation nuclei for the water vapor. And then added to that, you've got the heat that's been generated by the factories, the cars, the air conditioners, everything that uses electricity. There's not a lot of vegetation, so you tend to have the dark streets and dark roofs that have that low albedo. They absorb a lot of the sunlight instead of reflecting it, and that creates that urban heat island. Some of the things that we can do to counter that, planting trees and vegetation, using different materials to pave the roads and different materials on the roof so they're lighter in color. So if we can increase the albedo, then we're going to reflect more of that heat and lower the temperature. And then once again, we keep coming back to increasing energy efficiency for both cars, for buildings. One of the things that we are seeing in some areas, especially in a lot of the European countries like Germany, when they don't have a lot of land, is rooftop gardens. So that's going to help with removing some of the carbon dioxide from the air through photosynthesis, but also you're not going to have that low albedo like you do with the darker colored roofs.